Hi, welcome to the Calculus 3 lecture series. And we are in our first topic, is the vectors and the geometry of space. And this is the lecture number 2. So in the previous lecture, lecture number 1, we talked about the basic, like the R3 coordinate system, those things. So in the lecture number 2, we're going to talk about we're going to introduce a vectors concept and the several things about the vectors here, okay? So now let's take a look at what is the vectors here. Okay, so the vector, okay, so that means, okay, so first things, let's highlight a few important notes here. So what is the vector? So the vectors tell you is directed line segments. So, you know, if you give me 2 points, right? You give me A and B, I know the 2 points, I'm going to be able to make lines, right? But what is the vector? Vector say, hey, this is directed. That means the directions I do care. All right. So if this vector is from the A to B, then the vector can be written as, you know, you from the end point, you know, this is A is your initial point, B is your terminal points, right? So from A to B is a direction. So that means this vector is start from A to B. It's different than from the B to A here. So then the vector was defined as you use your terminal point, x2 minus x1 as your x coordinates, and then y2 minus y1 as your y coordinates here. Okay, so that's what is the first our definitions about the vectors here, right? So be careful about these notations here. So A is the initial point where it starts, B is the terminal point. Okay, so then next things here is like what is the position vectors here? Okay, so that's the another things here. We need to know what is the position vector and what is the standard position vector of lines here. So the position vector, so A is the position vector for the line segments from the 0 to P. Okay, so here, let's take a look at what we just did. You know, we said a vector A to B, right? So this is the vectors, right? So it's starting from here, go here, right? So that's why the arrow, so the arrow is going here, right? Okay, so it's A to B is here. So that means this is the vector's positions here. But then, you know, what is the standard position? So these vectors here, if you just move it down, right? So we talk about the standard position. That means I change the initial points to be our origin. So in fact, this OP and AB, they are exactly the same vectors, right? So that they have the same directions and the same lengths. Okay, so like in here, we said the vectors, you know, the 2 vectors, you know, if the 2 vectors, we say they are the same vector. So what type of, we have 2 conditions here. So first one, they need to go to the same direction. Okay, and then the next ones here is what? They need to have the same magnitude or the same length. Okay, so then when you move the vector, so this is where is my position. So this is the vector A, this is my position vector. Then when you move the initial point to the origin, then this is what we call is a standard position vector. So they can show, you know, this is the vectors, you know, go this way, and this is how long is this vector. Right. So the next things here we're going to talk about is the length or the magnitude of a vector. So if you give me a vectors here is like if you give me the vector is A1, A2, then here is the formula. The length is, you know, so the length will just be the A1 squared plus A2 squared. And here is the notation. It's kind of like the absolute value notations, right? So the reason why is like, take a look here. So if this is my vector A's, right? So A here, So here, if this is the point, A1, A2. Okay, so A1 is the x coordinate, so this is A1. And so this is the A2s, right? So I'm looking for the length of this vector, so it's this length, right? So that's why by the Pythagorean theory, that's what happens, A1 squared plus A2 squared and the square roots, that's the Pythagorean theory. Okay, so those first three definitions are pretty straightforward, right? Okay, so let's take a look. Then the next ones here is also pretty easy here. So let's say what is a unit vector? Okay, so the unit vector, that means if you find the length of this vector is 1, okay? And then the next things here we talk about is what is the zero vector? Okay, so the zero vector, that means this vector, you know, you use like the zero, like you bolded it, right? So we said that it's every element inside of this vector is zeros, right? Okay, so then the next things here, this is we call it state basis vector. So that's why we call this is a standard basis vector. So that means is the, you know, like if in R2, the unit vector, you have I and the j's, right? So I is 1, 0, and j is 0, 1 here. That means every vector, you can always write into a combination. Like, so if for the A, so if the vector A is here, so if the vector A is A1, A2, so the A1, this is the x coordinates, right? And this is the y coordinates. So this is x and this is y. So the x here, look here, that is the unit basis here. So this is the unit basis for the x and this is the unit basis for the y's here. So that means you can always write it as what? That's what is A1 times the I plus A2 times the j's here. All right, so for the R3, so if in the R3, okay, so what is your standard basis vector? So in the R3, we have x and y, z's, right? So my standard basis vector will be I is equal to what? It's 1, 0, 0. Then what is my j? J will be 0, 1, 0. And where is my k? My k will be what? 0, 0, 1. All right, okay, so that's pretty straightforward, right? Okay, so now next, okay, so now let's take a look at some of the practice problems. So let's practice. So this will be pretty easy here. So the vector, let's see here. So they say the vector represented by the directed segments, right? So be careful, it's where it from? From 5, 6 to 3, 7. So what is this vector? Looks like we can say, okay, I can call this vector A. So that's why you kind of bold the case. So it's from the A to B's, right? So that means you use the terminal point minus. So it's 3 minus 5 is what? It's negative 2, and 7 minus 6 is what? It's 1, right? So this is a notation. So we use this kind of greater than, less than sign as the vectors, right? If you use a parenthesis, what is that? That's the point, all right? Okay, so then the R number 2 is also, this is just R3 here. It's a directed line segment from this to this, right? So what is the vectors here? So you use the terminal point minus the initial point. So what is here? It's negative 5 and the 0 and the what here? It's 3, right? It's super easy here. Okay, so now let's set what the length of the vectors in the, you know, in the problem number 1 here. So you say, okay, the length for the vector A in the 1, in the problem number 1. So what is that we say? We use this notation, right? Kind of absolute value notation. So we use kind of like we use the Pythagorean theory. So it's what? It's negative 2 the square plus 1 square. So what is here? Square root of 5. Good. Okay, so if this is the number 2 here, I call this is vector B's here. So the length in the problem number 2, so this is in the number 2. So what is the length of here? Yeah, still is kind of like the Pythagorean theory in R3. So it's -5 to the square plus 0 square plus 3 to the squares, right? So this is 25 plus 9. So what is here? So this is what? 34, right? Square root of the 34. Okay, so now let's take a look here. So they said for the points A, B, C, D, and are the vector A, B, and C, D are equal. Okay, so the first, let's take a look at what is the vector A to B's, right? So this is the notation from the initial is A, go to B's, right? Okay, so this ones here will be the B minus A's, right? So it will be what is 4 and what is 6. Okay, so now the C and the D's here. C and D, so is D minus C, right? So it's 13 minus 7 is what? Is 6, right? Then -2 minus -11 is what? Is positive 9. Okay, so now if in here, if you take the constants out, so this can be 2 times this vector. So this is 2, 3. And this one's here, you can take this vector out. This is also 2, 3. Wow, so you see, the vector AB and CD is the same, like the same vector, it's just time a different constant. So are they the same vector? So we say if the two vectors to be the same, they have to have the same direction. So does this one, do they have the same direction? So what do they have the same directions? The answer is yes, right? Because they are only different by a constant here, but they all go the 2, 3, that directions, right? But do they have the, I should have put it the same direction. So do they have the same length here? Well, no, one is 2 times I is 1 is 3 times, so it's no's here, right? So are they the same here? Are they equal? So I know AB and CD, are they equal? No, they are not equal. So remember we said if two vectors, they are equal, what do they have to be? So they have to be the same directions and the same length. Okay? Okay, so sounds good. Okay, so now these are the basic, right? So now let's take a look at, do we know how to scratch the graphs here? So this one will be pretty easy also. Okay, so this is 2 6s, right? So let's do the 1, 2, 3, 4. Let's mark it. Okay, so 2 6. So that means let me give a little bit more colorful red. Okay, 2 and -6. So this is the point, right? So be careful. This is the point. So this is the point, and the 2 and -6. And because this is the origins, right? So that means I'll start from the origin. How I can do a good straight lines here, long off here, off a little bit. Okay. So now let's try again. I hate to do this. Okay, so here. Okay, so here shouldn't extend that. All right, so here, this is my what? This is my vectors here, right? So with the direction arrows here, add 2 to the -6 here, right? So this is my vector. I bolded it, right? A. Okay, now let's take a look at the next ones here. So I'm going to show you how to draw the 3Ds, right? Okay, so this is, let's make it. Okay, so it's 3, 6, 4, right? So the 3 is the x values, right? So you do 3, 1, 2, 3. So here's the 3. So the way we do it, you kind of draw a parallel line to the y-axis here, all right? And then the y is 6, so you count 1, 2, 3, 4, 5, 6. So 6 is here. So what you do here, you draw a parallel line to the x-axis, so they intersect here, right? And then the up is 4, so you do a line straight up parallel to the z. Okay, and then count the units, so it's 1, 2, 3, 4, so it's here. Okay, so this is the point, right? This is 3, 6, 4. And then the vectors, right? So the vector is from here to the point, right? So then you put the arrows there. So this is your 3D vectors here, okay? All right, so the next things here, let's take a look at number 6 here. The number 6 is asked, hey, is this vector is a unit vector? So what is a unit vector means here? Do we still remember what is unit vector mean? That means the length of the A is equal to what? Is equal to 1, right? So what is the length of the A? Do we still remember here? Yes, the length of the A is kind of like a Pythagorean series. So you kind of the square. So this is -1 and 4 to the square plus square root of the 3 to the 2, the square, plus square root of the 3 of 4 to the squares, right? So now if you kind of simplified, so this is 16, this is 1 plus 12 plus 3. Aha, I got the 16 over 16. So it's equal to 1. So if this is yes, we say yes. All right. Okay, so then the next ones here, they say write each term. So basically all those problems just try to test your terminology to see you remember all these new definitions, right? So here they say write each term into the standard basis vector. So I know these ones here, I can rewrite A because the 4 is x coordinate. So it's a 4i, so that both of these vectors, right? And then here is -3 is y. So what I do here, I will say minus what? 3j's, right? Good. Okay, so now the A's here is 0, 4, 5. So this is R3, so it's the same way. So I just have ijk. So I will have 0i plus 4j plus 5k here. So this is 4j plus 5k. Okay, now the C, and so they say, hey, can you write the C? C is the random is the vector represented by A and the B's here, right? Okay, so the first things here, let's try to find that the AB again is from A to B. So you need to use B to minus A. So this is 4. Got it? Okay, so this is 4. And then B minus 1 minus 5 is -4, correct? Okay, so this is R2. So I can say A. So A is equal to AB. So will be 4 what? 4i minus what? 4j's, right? So it's 4i minus 4j. So it's pretty straightforward. Okay, so now the next things here, we're going to talk about a few operations here, right? So, you know, for the vector additions here, right? So be very careful, vector addition. So if you have, so basically they tell you see here, so it's like they say, if the vector A is equal to A1, A2, then vector B, we need to do both faces here, right? Both it, right? So B is equal to the B1, B2. So algebraically, when you add A plus B, right? So just will be A1 plus B1 and A2 plus B2, right? So you just add the X coordinates and Y coordinates. And then from the graphing point, it's very important, right? So, you know, the A and the B's here, right? Okay, so take a look at these ones here, right? So the A and the B's here, if you put their origin, okay, so the A and the B's here, if you put their initial points here at the same points here, that means this is the both A and the B start, right? So you know the A and the B, they spend out a parallelogram. So if you take a look here, so they spread out like a really is a parallelogram. Okay, so then the A plus B. Okay, so the A plus B will just be the diagonal of this parallelogram. Okay, so still, you know, they start out from, right? So that you all start out here, so it's A plus B. How about A minus B here? Okay, so the A minus B here, what is the A minus B? Okay, so we know the A and the B, they span a parallelogram, right? So these ones here, the one, this diagonal is A plus B, and believe it or not, another diagonal from here to here, you know, A minus B, so your initials here, right? So here, that's the initial point. So this green vector is A minus B here. Okay, so that's the A minus B. And you will say, why is that? Okay, so let me show you why is that, all right? Okay, so let me erase all these things I just did. Hey, how nice, I can erase it. Haha, that's pretty good. Okay, so now in here, the A minus B here, I really can write as A plus negative B's, right? Okay, so B from here is go this direction. If you add a negative sign, what's that mean? That means this will be the B's, right? And go boom, 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 right? So I go the opposite direction as the B with the same length, right? So this is a negative B, correct? Right? So this is a negative B. Then we know A plus A and B. So whenever you have a 2, they span a what? They span a parallelogram. So here, so this is a parallelogram. They span the parallelogram. And then we know from the previous, so the parallelogram, so what happened to here? So this is, this is the green better, it must match. So this is the diagonal, right? So this is a diagonal of this parallelogram. So this diagonal, the green one, so what is the green ones here? So this is A plus negative B, so it's A minus B, right? And then, you know, if you do a move, you move this one up here, right? So it's a parallel, so really, so this one is equivalent to this one, right? You just, like we talk about the position vectors, right? So you're just moving up. So this one and this one have the same direction, same length. So that is why, you know, the other diagonal is the diagonal. That the other diagonal is A minus B. The key things here is A minus B. So which direction goes, right? So that's why here you need to be careful. The initial going to start at the one, whoever is minus. All right, so this is A minus B here. That's what is the initial going to start. So like if I have a B minus A here, right? So if here this is A, this is B, right? Okay, so you spend a parallelogram. So of course, this one's here, this one is what? This is A plus B, right? Then another diagonal will be the minus. So here, because we say this is the B minus a, right? B minus a. So I know the direct, so B minus a is another diagonal, right? So it will be this red diagonal. But where it start, where it end, you start at the negative one. So that's what is go this direction here. So you put your arrows this ones here. All right. Okay. Okay. So now let's take a look. So it's very, very important, right? So the the addition and the subtraction. So the addition it will be the diagonal. Then the subtraction will be another diagonal. The only thing here, when you do the subtraction here, which is the initial side, which is the terminal end, right? So the one with negative is with the initial, right? Okay. All right, so now let's take a look at what we have, the properties. So those are pretty simple. So if you add two vector, you can switch that. That's what we put as commutator properties, right? Then this is, if you A plus B plus C, so you put the parenthesis to the A plus B first. So that's fine. Then if you add a zero vector, will be itself. So it's kind of like in the real number, you add zero, it still will be the same thing. Then a plus negative a equal to a zero vector. So it's just like in the real number, you add a negative number will be equal to zero. Okay, so here, this is a, this one's here, be careful, right? So this is they don't have both the face, that means this is a constant. So you can use the distributive property, so you can become the CA plus CB. So if you have two constants, you can do the distributive property also, right? And then in here, this is we call the associative properties, right? So you can do the C times D constant, or you do a D constant first and then times C. Right, and then the 1 times a still will be a because 1 is a constant. So make sure, be careful, those things without bolding, that means they are the constants, right? So the 1 is bolded. When you bold it, that's we demonstrate as the vector. Okay, so let's take a look at what is the other problems we have. All right, so this one is pretty straightforward, right? So let's try to, so what is a plus b? That means just a plus b's, right? So it's a vector. So what is here? So this is a negative 5 plus 4 is a negative 1. So what is 3 plus 1 here? It's a 4. Super easy, right? Okay, now this is a constant times a. So what is here? Is 24 and what? 18, right? Okay, so now they want to sketch the position vector of the b minus a. So this is interesting. So let's take a look. A is 4, 3. So 1, 2, 3, 4, 1, 2, 3 here. Right, so this is A, right? 4, 3. So okay, so this is 9, 8 here, right? So this is A. Then B is 24. No, the B is negative 5 and 1, right? So it's 1, 2, 3, 4, 5, and the 1 here, right? So now 1, 2, 3, 4, 5. Okay, so it's disappear on me. Okay, so here. Oops. Try to graph a line. It's kind of difficult. Okay. 1, 2, 3, 4, 5. Okay, so here you go. That's well, finally, kind of good. So this is D's, right? Okay, and this is A, right? So this is A here. And then the B minus A, you can really just say, okay, so the B minus A, if I calculate, so you use the B minus A, so what is here? Negative 5, negative 4, so it's negative 9, B minus A, so negative 9, negative 2 here, right? Okay, so the position vector, so it's a negative 2, negative 9, negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, negative 2, 1, 2, so it's here. All right, so that is a rule here. Okay, so that is rule. not easy to draw here. So this is B minus A here. Okay, so let's verify what the B minus A, I shouldn't go all the way to here. So I should just stop at here. Right, so -2 and 9. So this is B minus A. Okay, let's try to use our definition. We say that A and the B, they span a parallelogram, right? So let's kind of draw a parallelogram. I know that because of my drawing here, probably, okay. All right, so this is the parallelograms, right? So your adding will be this, right? So will be this, will be this diagonal, right? So will be the diagonal from, from here to here, right? When you add this, right? Okay, so now when you subtracting will be the other diagonal. So that means will be this diagonal here, right? So then we say this diagonal. So where is the initial point? Where is the terminal point? So we say because the initials have to start with the negative. So A is here. So B, stop at the B. So this is what? Did you see here? So that is, so then as you can see, this is B minus A. So as you can see, these two are parallel and have the same lengths here. So we know we did the correction. All right, okay, so that's very important, right? So you need to remember. So I think for this lecture, the only things a little bit hard is how do you graph the A plus B and the A minus B, right? So one is one diagonal of the parallelogram and other one is another diagonal of the parallelogram. So you need to be careful. The only thing you need to be careful is where is the initial point and where is the terminal point, all right? Okay, number 9 is super easy. So 2A plus 3B is here, right? So it's 2A plus 3B. So you can just write this is 2A. So will just be 264, right? And 3B is what? Is 6, 3, 18, correct? 6, 3, 9. So you add it. So this is super easy. So when you add it, it will be what? A 9, 22. All right, so I expect everybody know how to do this. Okay, so I like those true and false questions, and so those things will test your understanding. Okay, so the first one is here. So it's C times A minus B equal to CA minus CB, and then I notice here the C is not bold, so it's a constant, right? So I know the distributive property work. So this is true or false? Hey, this is true. Okay, so now the next one's here is 0 times A is equal to a 0. So both 0 is not bold, so it's a constant. So it's 0 times a vector A is equal to 0. Is true or false? This is a false. Why? Because when a 0 times a vector, then the end result still has to be what? Still has to be a vectors, right? So that's why when you say 0 times A, so I bolded the A, then here this will be 0 vectors. It's vectors here, right? So like you can see the example, if A is equal to, let's say 1, 2, 3, then the 0 times A will be the 0 times every item. So it's 0, 0, 0. So this is still is a 0 vector, right? So that's why I need to bold it. So it's not a 0 constant. All right, so that's it. Pretty good, right? Okay, last one, see last few problems, and then we're done here. All right, find the unit. Okay, so this one's here, they say, hey, this one's here. Based on these directions, right? So I want to find a unit vector and have the same direction as the 4, 3, -1. So how do I find it? So I say, okay, let's first take a look at what is the length of these vectors, right? So the length of this vector is 4 to the square plus 3 to the square plus -1 to the square. So what is the length of here? So this length is the square root of 26. Right, I hope that I got that one correct. Okay, so then the unit vector will just be what? Will just be the A vector divided by the length here. So this unit vector will be 4 over square root of the 26, 3 over 26, and the -1 over 26. Haha, because they are, right? So in here, take a look, they are different by a constant. So I know if two vectors, they are different by a constant, they are what? They are, you know, they are going to the same directions, right? They go into the same directions. And then now, because you divide by the length, so if you want to find the length of this vector, what is will be 1, right? So if you find the length of this vector, you can write these ones here. So 3, 26, and -1, 26. The length of this one, you put here, the length is 1. So that's what is a unit vector. All right. So number 12 is super easy. So I just want you to practice the standard basis vector. So A plus B. So what is A plus B? So we say is what? A plus B is 9I plus 5J plus 2K. Correct? Okay, -2B. What is that? So that would just be -4I minus 2J minus 10K. Of course, those IJK is vector. Right here. Okay, so now number 13, let's say it's 4A6 and then -2, -2, 3, -4 are parallel now. Well, let's take a look at the 4A6. I can take the what out? I can take the constants 2 out. So it will be a 2 times the vector 2, -4, 3, right? Okay, then the B is 2, -2, 3, -4. Well, seems they have the one negative sign. Okay, let me take a look at the negative sign out. So this will be -2, +4, -3. Okay, so the negative sign match, but do they have the same value? No, right? This is -2, 4, -3. This is -2, 3, -4. So they're not the same. So are they parallel? No, not parallel. All right. So the only thing that would parallel if you know, whatever this vector and this vector, if they are the same vector, all right? Okay, number 14 is here. Okay, so this is our last problem in this lecture series. So they tell you a plane is heading the north into 200 km/h, but there is the west to east crosswind pushing the plane eastward 40 km/h. What is the true direction of the plane is heading? Okay, so here, this is the plane. I'm heading the true north, right? I'm going to north. And then a wind pushing it, right? So wind is go like this. Or maybe I use a different color to be better. Okay, so then I have a wind. Yes, wind, I've used the green here. The wind is pushing from the west to east, and this wind here is 40 km/h, and the airplane flying north on the 250, right? So you know your airplane finally going to fly like what direction? Your airplane going to fly in these directions, right? Because it's have the airplane power and the wind powers, right? So they say, what is the true direction of the airplane flying? Because you can see this is the vector, right? So this is the vector, and this vector really is the 0 to 50s, right? Because you only go to north, that's the y-axis. And then this vector here is wind, is 40, so this wind basically is what? is 40, and what is here? This is zeros, right? So the ones here. So then this red one, so what is the red ones here? The red one is just these two add, right? So this is on the 40 and the 250s here. And I want to find the true direction. That means I'm looking for this angle, right? So this angle theta, right? So how do I find the angle theta? I can use tangents, right? So I say tangent theta is opposite over adjacent. So it's 40 over 250. Then the theta will just be arctangent 40 over 250. If you put it into your calculator, you can get about like 9.1 degrees. All right. So the true directions here, the way you know this airplane flies what is the 9.1 degrees east due north, right? Okay, that's it. And so this lecture is a pretty basic lecture, all right? So we are still in a very, very basic level because we are trying to introduce all the different notation. So the things to remember in this lecture, the key things here is that if two vectors are the same, they have to have the same direction and the same magnitude. And then the next thing is important is how to add and subtract two vectors, right? So algebraically, it's very easy how to add and subtract. But then I really want you guys to remember is the picture one. So where is my picture one goes? Oh, here is the one, right? So the A and the B's, right? So remember that they suspended to a parallelogram. So adding is one diagonal and the minus is another diagonal here, right? So the key part here, so which diagonal, which one to start, which one to go, that is important, right? So that's very important because this negative sign decide, you know, the initial point is start at vector B and ending at A here. I guess that's it, and it's a very easy lecture series. Okay, so that's it, and hope you understand the concept. We're going to get a little bit more complicated in our next lecture series. All right, so that's it. Have a good day. Bye.